Hi there, and welcome back to CIS 258. For week 3, we are going to be covering a couple topics in 2 chapters in your text. So I want to kind of briefly go over and introduce you to these topics that we'll be covering this week. The first chapter you're going to be reading is dimension reduction, which is has to do with the curse of dimensionality, which is going to be some videos that you're going to watch on this, as well as some of your homework applies to this as well. A lot of getting to understand data mining is understanding the terminology that's being used. So for instance, in this case, when we talk about dimensions, you may have an idea in your head about what dimensions means to you, maybe from a math perspective or an art or graphic design. But in data mining, dimensions refer to the attributes that make up a data set. So it's the columns in those data sets, not the records or the rows, but the individual columns that exist in your data set. For many algorithms, having too many dimensions causes some problems with the algorithms. They don't learn as well. They tend to get more confused. You get kind of results that are not very helpful or don't have strong predictive ability. So for instance, clustering is one particular algorithm that does not do well with a large amount of dimensions. When I'm saying large, I'm saying you might have a data set with 200 or 250 attributes. That is something you would not want to just throw a clustering algorithm at before actually trying to decrease the number of dimensions. And there's a number of ways to do that using various methods, including information gain. There's a method called PCA, Principal Component Analysis, which kind of compresses the data, and some other various methods by which you can determine which dimensions are going to be the best for your algorithm that you're trying to use. So you're trying to get better behaved data. So that's part of this process of dimension reduction. It is actually a really important part, especially as you start working on your projects. You're going to find that there's lots of data sets out there with tons of data, but you want to make sure that whatever data you are using, that it's going to end up giving you good results in the end. So you're going to learn a little bit more about this dimension reduction issue. The second chapter is evaluating predictive performance, which it's going to be really talking about metrics, ways that you measure the results of various classification algorithms. For instance, in classification rules and decision trees, you'll see that there's all these different metrics and measures called accuracy. There's something called a confusion matrix, lift charts, there's precision and recall. And also you're going to learn a little bit about stratified sampling in this particular chapter, which is actually a really important tool to use when you've got data that is skewed. And I give an example here in the text explaining what happens. And as we've seen in previous weeks, that the algorithms do not learn as well when you are giving it skewed data, meaning that you've got too much of one particular classifier than the other. So if you're looking at good or bad drivers, you want as many good drivers as you have bad drivers so that the algorithm can actually learn how to equally predict both good and bad drivers. If you give it too many good, it'll get really good at predicting good, but it won't be very good at predicting bad. So stratified sampling is a technique we use to address the skewness factor. I'm also providing the PowerPoints. They're not narrated, so they're just for you to read through if you wish. It kind of helps summarize what you're reading in the chapters. I also have some videos for you to watch, and there's 2 homework assignments for this week. One is an Excel minor, and one is a discussion board post similar to last week. So let's go into the next section here so I can talk a little bit about the reading. So I want to touch on, so here you have these 2 PowerPoints, but then down below you have these URL links to websites that I want you to look at. So the first one is on lift charts. For lift charts, what I'm really wanting to make sure that you understand is how to read a lift chart. I'm not really so much concerned that you know how to calculate it, but that you know how to actually read that particular chart. So this first chart here that we're looking at, you can see the pink line is what we consider the baseline, and then the rounded line is the actual performance of the algorithm. And if you go up to the top of this, you'll see that the definition here was one of the best definitions I've seen on lift charts. But basically it's showing the effectiveness of a predictive model based on the results obtained with or without that predictive model. The cumulative gains in lift charts are visual aids for measuring this model performance, both charts have a lift curve and a baseline. So the baseline is what would happen if you didn't have the predictive model at all and you're just randomly choosing things. So it's basically a baseline measure that we're using to determine what the baseline performance would be if you did not have a predictive model. The greater the area between the lift curve and the baseline, the better the model. So looking here at this lift chart, we have this baseline model, this baseline curve here, and then we have the lift curve, and you can see this area in between. The more area that exists, the better the model. Down here we have a second example of a lift chart, where you can see here that in the beginning it looks like it's actually there's a wide space between the performance of the model and the baseline, but as you start adding more customers contacted, it starts decreasing to the point where by the time you are contacting 100% of your customers, it's basically the same as the baseline. So you're trying to determine what is the best point of actually contacting your customers. So the most bang for your buck, so to speak, is contacting 10% of your customers, because you're going to end up with a lift chart measure of 3 as opposed to 1 with the baseline. So we'll make sure that you understood how to basically interpret these charts, understand how to look at them, and evaluate your models. The second link that I wanted to show you is on classification measures, which classification is both for classification algorithms as well as decision trees, which decision trees really are classification. It's just being portrayed in a different way. So if we go down here and scroll down a little bit, I would ask that you read through all of this. I'm not going to read it to you, but I want you to understand in particular the confusion matrix. So if I look down here at the CART confusion matrix, CART is a type of decision tree algorithm. It's a very popular one actually in statistics. But this is showing the table that is part of the output of a decision tree or a classification algorithm. So here you have recurrence and no recurrence. Those are the two outcome measures. So these are the actuals. And then here is recurrence and no recurrence. This is what's being predicted. So the way you read this is you read it diagonally. So here we have 10. There's actually 10 records that were actually showing recurrence of breast cancer, and it was actually accurately predicted as 10. And down here we have 188 were predicted as not having breast cancer, and that was actually correct. And the errors are here. So 75, it said it was recurring breast cancer, and when in fact it was not. So it's a false positive. And up here we have 13, which is saying that there was no breast cancer when in fact there actually was, so that's a false negative. In medicine, these two measures are actually really important. They're called sensitivity and specificity. False negatives, this 13 measure, is what medical doctors would be most concerned with. It's the fact that it's much lower than the false positives is good. But this would be an important measure, because obviously with any kind of medical diagnosis, missing a cancer diagnosis is far more serious than misdiagnosing someone with breast cancer when they actually don't have it. And the way that you would, from this measure, would get a accuracy measure is you would add up the correct number. So we have 198 divided by the total number of all the records, which would be 201, and that would give you your accuracy measure. You'll see down here they'll talk about precision and recall as well, and these are, like I said, this is actually related to sensitivity and specificity. So precision is the number of true positives divided by the number of true positives plus false positives. And then recall is the number of true positives divided by the number of true positives and the number of false negatives. So they're using different parts of that to come up with these two different measures. So again, read through these, make sure that you understand them, but in particular, make sure you definitely understand how the confusion matrix is set up and how to calculate accuracy from it and be able to interpret it. Next, I'm going to quickly review the videos here. So you have the confusion matrix video will help you in understanding how the confusion matrix is set up, and then again all the calculations that go along with it. I can tell you that this will be on the exam. so you'll want to pay attention to this. Cursive dimensionality is explaining why it's so problematic to have too many attributes in a data set. There's two videos that are continuations of one another, so please make sure that you watch both. I think it will be very helpful in explaining that problem of dimensionality to you. And then down below here we have homework assignment 3, which you will be using Excel Miner. So if for some reason you're continuing to have problems with Excel Miner or start having problems with Excel Miner, please let me know, because I can give you access to the virtual PC using hat size, and you just need a username and login, and you can get access to this online version of a PC which has Office installed on it as well as Excel Miner. So don't feel like you need to struggle with Excel Miner if it's not working for you on your PC. So in this, you're going to be using Excel Miner for 4.1, and then 5.1, you're going to be creating a confusion matrix with Excel or a table in Word, and you're going to be calculating the error rate and including it in your Word document. Next, you have a discussion on data mining gone bad. There's a link that I'm providing to you on the dark side of data mining, kind of getting into some of the ethics of some of the issues that have gone on. So as you're learning some about the technical aspects, I want you to also be aware of the societal impacts and philosophy and ethics behind data mining. You'll also notice there's solution files here, which some will open up right away. For instance, you should be able to see the PDF right away, but you won't be able to see the Excel spreadsheet until you submit something and the deadline has passed. So that's how you'll be able to see that by next Monday. So again, keep working ahead. So far, good job everyone on your discussion board post last week, and I will be getting to grade your homework 2 this weekend, or hopefully by Friday. In the meantime, I hope you have a good week, and let me know if you need any help with any of the content.